I will show you here the new features of the new version of CupCarbon Simulator. Here it is the version here it is the version 5. So the version 5, we do two main improvement. The first one, I'm talking especially about the send script. So the first improvement is that we don't need dollar to use dollar for the variables, and the second one, so now to send messages, you have to, if they are string messages, then you have to put it between commas. So let's first create a project. Let's say introduction, or just test. Let's go test like here, and then we add some nodes. For example, just one for the moment. I'll just put here the white interface, the white background. Sorry. So the first code that we can write with CupCarbon is just the hello world. We call it just hello here. And then you can just here put a print. So as you can see, hello world. Now we have to write it like this. In the previous version, we were just like this, but now it can't work in this version of or in the version 5 of CupCarbon, because these values or these words here, hello and word, they will be considered as variables, because we don't need to use dollar for the variables. So if you remove this, then this sentence will in this case will be considered as variables. So to say that it is a string, where we write here hello world, then we can just stop the simulation here directly and call the file hello here, sorry, hello, like this, and then we have just to assign this code to this sensor and start the simulation using this button here. As you can see here, hello world. And we can, for example, just do some improvement. Let's say set x 0, and we'll just write hello world 0 and 1, 2, hello each second, for example. Or we can just put inc x or set x plus 1. So we don't need to use dollar here. A delay of 1 second. Then here, if we run the simulation, then you can see hello world 1, 2, 3, 4, 5, and so on. So now let's create two sensor nodes, and the second one the first one will send these values. It can print it, but send it to send x. So when we put send x like here, it means that it will be sent in a broadcast, and then we will increase the value of x, and then we'll display it each time, each 1 second here. I will save this code, hello code. Then I will write the code of the receiver. So the receiver, we can write it by wait and read x, and then display it, print x. So we don't need dollar here, or we can also write receive x and print it, and that's it. So we call it the rec for reception. Just will assign, you can do right click here directly and assign script rec, and then we can maybe increase, it's okay here for this version, and we can run the simulation, and you can see hello world here, it's the same here, and it prints the received values here. You can see the send values here, 8, 9, okay, like this. This is a broadcast sending. So to prove it that it is a broadcast sending, we stop simulation. So let me just change a small thing here in the receiver. I will just print here, I have received X like here. So if I run again the simulation, I have received 0, I have received 1, I have received 2, and so on. So if I add other nodes here, and the other one here, for example, 3 nodes, and then I will assign, with control button, I can do multiple selection, and then I can assign the reception again here for these 2 others. So I can, for example, just remove this. I can, with A key, remove the arrows here, and L the links, as you want. So you can just do it like this, or like this, or like this. You can do it by this too. So let's take just the connections and start the simulation. So you can see here, I have received 1, I have received 2, I have received 4, all this. This is the broadcast sending. If you want that S1 will send a message only to S2, then just in the reception code, no, sorry, if this is the sender, just say send X to 2, like this, 2, then you will see that it sends a message only to the sensor not having this, the ID 2. If you click here, you get the ID here too. You can change it, of course. And then you can send to a group. We call this type of sending a multicast sending. So here we have the my address. It's called my address. When you use, for example, the XP modules, this is the same. They have the same my address. Let's, for example, we'll create a group here with this 2 nodes. So in this case, we have to change their my. You can find it in the radio parameters, and if you find the my here, let's put, for example, 4, and the my address is 4. My address for that one is 0, and the my address for the S3 is 20. Let's change it by also 4, which means that these nodes, they have the same my address. They belongs to the same group. Then in CupCarbon, we can say, if we put 0 here, which it means that it uses the my address, and I use 4. So I'm sending to the my addresses that have the value 4. I will save, and then I will run the simulation. So as you can see, all the sensors having my address equal to 4 will receive this message. So now let's go to another example where we'll try to do the routing. So let me just use this sensor here and the other ones here. So here, this node will send the values to that one, and that one will route it to that one will route it to that one, and that one will display or print the message I have received, the value that this node has sent. So for the hello, so let's say that it will send a message to S3. I'll change it here to, it's a direct or unicast sending. It sends it directly to the 3, to the node having the ID 3. And 3, it will be a router. So I will create router 1 or router 43. I will call it router 3 for the sensor node 3. 3, it will wait for message and receive the value from S1, and it will send it directly to S2. So send X to 2. This routing process, written of course in this with the same script here. So the router 3 means that this sensor node will receive a message, wait for a message, and when it receives a message, it put it in X value, and then send it to the sensor node with the ID 2. And we will write the same code. So let's take router 3, and we will call it router 2 for the second here. I have just to change 2 here and here. It will route the message to the S4, which means to the ID 4 here. I will save it. And the last node, the receiver, the code remains unchanged. And then when it receives a message, it will just print the message I have received, the X value. Then just we'll send here, we'll assign the script router 3, and we'll assign the script here router 2. And then let's simulate and see the result. As you can see here, it sends the value hello world 2. It sends the value 3, 4, and it increases each time, each second, this value. And then, as you can see here, it is routed to the sensor node 4. You have another option of routing values. It's, let's say, a generic router. I will call it a router. This, we can write it like this, but it's really a CupCarbon function. But I don't know if the simulator, if in the reality we have this kind of function, but of course if you can write it in the simulator, then it's okay. If not, so just, I think in this case there is no functions generic like that one, but it can help just to write some scenarios and go quickly and design some examples so in an easy way. Here, for example, I will wait to receive any message, and when I receive a message, I will send it to send X to all the here star here means in a broadcast, which means to all my neighbors, but not to the one from which I received the message. In this case, we need to know the ID. So here I can't write it because I don't know the ID. What we will do, I will save it as it is here, but it is not it's not correct. So just change it. I will change it after and correct it after. Just will change another manner to send messages, which is, I think, the good manner to do it. For hello, in general, let's write the function that get get ID. Get it means I will use some 80 commands, and I want to get the ID of this sensor, and I put it in a variable ID. Of course, here you can use Y and use E, you can use what you want, A, E, I, or K. I prefer to use ID. So this is the parameter I want, the ID, which means the ID of this sensor node, and I put it in the ID variable. And then I will not send X to 3, but I will create a message with the command data. I will call it this is message, and I will put in this message the ID value and the X value. And I will send the message. So on the other hand, for the router here, it will receive a message. I call it, I can leave X here, there is no problem, but I prefer, just for a good organization of my code, to use message like this. And before I use air data, which means read data. air data message. I will read message and put the first value in the variable ID and the second value in the variable X, and then I will send now the message. Of course, I need to create a ticket ID, and I put it in the variable ID2. This is the ID of the current router, which means that now I have to create another message. Let's say message2. I can put the same variable, but I prefer to change the name here. Message2, and I put the ID now. But here I prefer to use RID for the received ID. This is the received ID, and this is the current ID. So data message2 I created with the current ID and the variable X, because I want to route this message X. And then I will send the message2 now to all the neighbors, which means in the broadcast, except one node. It's the RID, which means I will route my message to all the others except the one who sent me the message. That is why I use the RID here. The advantage of this, we can write it once and use it for all the routers. So we don't need create, as in the previous example, a script for each router. So this can be used for all the routers. Now we go to the receiver. As we can see, as we know now, that this is a message, a data message, RID and X. Of course, just I save it, I go back to the router. So this is X, but I can also call it RX for received X, but it's the same. Since in this case, the received value, it will be the same that one that we want to send, that we can give it the same name. So it's not a problem here. So for the receiver, I will use exactly the same name for the received value. This is the received ID and the received value, and I will just print the received value X here. I hope that it will work. So here it will be the same code. Here we will use the same code, but for this routers, I will use the code router. It's the same code, as you can see. So let's start the simulation. It works. There is a problem here for X. So let's display or print the values received by each router. And as we can see here, there is a problem of the value null here, which means there is a problem. Let's correct it. So, which means the X here is the command air data. It's not air date. Okay. So I hope that this time it will work. Okay, it's good. So 0 and 1, 2, and that's it. We can accelerate a little bit the simulation by put 500 milliseconds here. No. And also accelerate the arrows, the red arrows time here. As you can see now, it works. And the advantage with this script, so I can put, for example, the sender here, the transmitter, and the receiver here, and I can add many nodes between them. As you can see here, till that one, and then or there are routers here. Use control to select many nodes. Router. There is one code for the router. So if I simulate now, sorry, there is a small problem. Just I think it's the symmetric links. Where is the problem? So there is a problem here, but I don't know. Normally it has to work. I just increase the time here. No, there is no thread. Sorry for that. So I don't know exactly why it doesn't work. Let's just go to the previous example. Okay. Oh, sorry. So yeah. This is the problem in the first sensor node, which hello here, it sends a message to the 3 sensor node 3. Since this node is not 3, so that is why I can either put here this node 3, change the places here, and now we can see that it works. I will accelerate a little bit the simulation. And the problem just here, I will put this. This is the receiver, and that one is the router. Okay, now it will work. As you can see, it's wrote the message until this last node. We can also use just a broadcast sending from hello. So in this case, you can use here, just send message. We don't need to know the name. So even I change the place with that one and put this node here, then it will work. Yes, as you can see here, we can add some option, like for example, in the receiver, we can say if, let's say, calculate some modulation. I think that can say set y is equal to x modulation 2. If y equals 0, then I will mark the node. Otherwise, I will unmark like this. Which means that if the modulation with 2, which means that it's an even value, not odd values, then we mark the node. Otherwise, we'll unmark the node. And you can see 0, it's marked. Now it's 1, it's not unmarked, and so on. Thank you, and I think now this tutorial helps you to start using the version 5 of CupCarbon. See you in next tutorials.